Here's another good stoichiometry problem. In this reaction, gold sulfide, it's actually gold 3 sulfide, reacts with hydrogen gas to form H2S, which is the rotten egg smelly gas, and to liberate gold metal. Now, the first thing you want to do in a situation like this is always to balance the equation. So I'll start by balancing those sulfurs. There's 3 on the left, and so I'll make 3 on the right. And then everything else just kind of comes along for the ride. I've got to have 2 golds on the right and to match the 2 on the left, and then I clean up with just balancing the hydrogens. Well, we're reacting 500.2 grams of gold 3 sulfide with 5.67 grams of hydrogen gas. Whoops, I wrote that off the page. Sorry about that. And so this is the limiting reactant problem. We don't really know, just by looking at the masses, which reactant is going to be the limiting reactant. So what we've got to do is check each of the reactants and just ask how many moles of gold metal would that mass of reactant make if there was an unlimited amount of the other reactant. So we'll start out with gold. We have 500.2 grams of gold 3 sulfide. And we know that in 1 mole of gold 3 sulfide, there are, I believe, 490 grams. So 490 grams of gold 3 sulfide in 1 mole. And then we can use the mole ratio from the equation, which says that for every 1 mole of gold 3 sulfide, we produce 2 moles of gold metal. And that's very important, and it comes from a balanced equation. And let's cancel our units just to make sure that we end up with the right units, and we do, moles of gold metal. And if we do that calculation, we see that if we started with 500.2 grams of gold 3 sulfide, we would end up with 2.042 moles of gold. And now we want to do the same calculation with the hydrogen gas. We start out with 5.67 grams of hydrogen gas. And we know that in 1 mole of hydrogen gas, we have 2 grams. It's 2 grams per mole. So we just organize our fractions here so that the units cancel. And then we'll use our mole ratio again. We know that for every 3 moles of hydrogen that's used, we produce 2 moles of gold metal. Okay, cancel units and do this calculation on a calculator. We end up with 1.89 moles of gold metal produced. And so it's easy to see here that hydrogen is the limiting reactant. It will produce the least amount of gold metal. What that means is that in this reaction, all of the hydrogen is going to be used up, and there'll be a little bit of gold 3 sulfide left at the end. Now, if we assume that all of the hydrogen gets converted into this reaction to liberate the gold, then we have 1.89 moles of gold, and 1 mole of gold is 197 grams per mole. So cancel those units, and we end up with 372 grams of gold that would be produced, or that could possibly be produced in this reaction. Now, if we're clever, we notice that we probably could have done this calculation. We probably could have determined which reactant was limiting without going through some of these calculations. If you look at the left-hand side of the equation, it's 1 mole of gold 3 sulfide for every 3 moles of hydrogen. And if we go up to our calculation and kind of stop in the middle here, we notice that this calculation gives us about 1 mole, or actually a little bit more than 1 mole of gold 3 sulfide, but less than 3 moles of hydrogen gas. So that right away tells us that hydrogen would have been the limiting reactant. So as you get further along in working through stoichiometry calculations, you might be able to see some of these shortcuts, but be careful at first.